So again, this session we'll cover that under the basic concepts, research questions, assumptions and hypothesis, commands and interpretation, and summary. So the research question can be like if you want to know whether there is any relationship between the serum vitamin D level and serum calcium level, then we can use this bivariate correlation. If you want to know whether there is any relationship between the sleep duration and percentages of marks obtained in the final examination, and this bivariate correlation, we are doing the Pearson's correlation because there are many types of correlation also. There is something known as the biserial correlation. There is something known as the Kendall-Tau. So we are not covering all those type of correlation. There's a Spearman also, but we are only restricting to the Pearson's correlation. So you want to know whether there is any relationship between the sleep duration and percentage of marks obtained in final examination of MBBS student. So these both are on the continuous scale. Similarly, if you want to know whether the female literacy rate and infant mortality rate is related or not, then also you can use these correlation, bivariate correlation. So in all these research questions, what have you seen? That there is a continuous variable and there's a one continuous variable and you want to see the relationship with other continuous variable. So the appropriate statistical test for such type of research question is the bivariate correlation, which is also known as the Pearson correlation. So correlation, it is used to determine by the correlation, we determine two things. We determine the strength of association and we determine the direction of that relationship. So it has got two things, value and a sign. So if the sign is positive, we say it's positive correlation. If the sign is negative, negative correlation. And if you make categories out of continuous variable, like if you are making categories of a serum calcium level, vitamin D level into like less than 10, more than 10, or calcium level like less than 5, more than 5. Similarly, if you are making categories of sleep duration, percentage of marks, female literacy, and infant mortality rate into low and high, then you don't use this Pearson correlation. You cannot use this. So there are some underlying assumptions for this correlation. There should be a scale variable. Both the variables should be of a scale variable and it should be a paired value. So remember in paired t-test, we done about the paired values. Similarly, here also the two variables should be of the same individual. That we know by the paired values. And there need to be a linear relationship between the two variables, which we check by the scatter plot. There should not be any significant outlier. And we need to satisfy the assumption of normality. And by doing the descriptive, we know that you all have the data for the box plot and the QQ plot of your continuous variable. So there is something known as the correlation coefficient, R, and it is also known as a Pearson's correlation coefficient. It has got some properties. So this R measures the strength of relationship, that is the linear relationship. The sign of this R, that conveys the direction. So we have discussed that if it is positive, it will tell that it is positively related. That means if you increase one variable, the other variable will also increase. The third is your magnitude. So magnitude of the R conveys the strength. And it ranges from -1 to +1. And again, this correlation does not imply causation. So if to say that a particular variable is causal, there are some other criteria. So now coming to the strength of association, if the value of correlation coefficient is less than 0.3, we call it as a small correlation. If it is 0.3 to 0.5, we call it as a moderate correlation. If it is more than 0.5, then we call it as a strong correlation. So this is a linear and non-linear relationship. If your scatter plot is something like this or this, then it is a linear relationship. If your scatter plot is like this or as like this, then it is a non-linear relationship. Now there is something known as the coefficient of determination, which you have done actually. So suppose you find out the correlation coefficient of the two research questions, like serum vitamin D and serum calcium, sleep duration and percentage of marks, state literacy and infant mortality rate. So the correlation coefficient of these three are like 0.552, 0.702, and 0.801. So this tells regarding the strength of association, and all these correlation coefficients says that there is a strong association because it is more than 0.5. Again, the sign tells the direction. If you square it, but if you want to know how much the variance in one variable can be explained by another variable, like the variation in serum vitamin D level from one person to another person can be explained by serum calcium level by what percentages, or the variation in the percentage marks obtained from one student to another student can be explained by what duration of sleep, and again the variation in the infant mortality from one state to other state can be explained by literacy rate by what percentages. If you have to answer such questions, you need something as R square, which is also known as the coefficient of determination. So you square the R values. So like 0.55 R square will be 0.30. Similarly, this will be like 30%, 0.492, that is the 49%, 0.64, it is the 64%. So you can say that the variation in state literacy, so you can say that because in this case, the dependent variable is the infant mortality rate. So you can say that 64% change in the infant mortality is dependent on the state literacy. Similarly, percentage of marks, you can say that this is the dependent. So changes in the sleep duration is responsible for 49% variation in the marks of in the percentage marks. So that's how you calculate and they interpret the R square. So what will be the null hypothesis? So null hypothesis will be that the population correlation coefficient is equal to 0, whereas the alternate hypothesis will be that the population correlation coefficient is not equal to 0. So coming to the demonstration, so this is my sheet of the, I'll open this question. So the question, I have to apply the correlation between the BMI and cholesterol. So you have to write in the table, and then I have to do the multiple correlation also. So multiple correlations means I have to do the correlation between the cholesterol, cortisol, and vitamin D. So I'll open the GEMOV. In GEMOV, on the same option like regression, you click on this correlation matrix. So here you can see that there is only single window, and you need to enter all these variables in this window. So first is the BMI score and cholesterol. So two variable. This is the only bivariate correlation between the two variable. Then if you come down, you can see other options. So I hope that you have checked with these variations and these are normal distributed. If not, you can click this Spearman because this is the non-parametric. But right now, this Pearson is clicked. If you want your significance to be star marked, then it will flag the significant correlation. And if you want the confidence interval of this correlation coefficient, it will give you the confidence interval of this correlation coefficient. So what can we see here? That the value of correlation coefficient is plus 0.675. That means it is a strong correlation because the value is more than 0.5 and the direction is plus. That means if you increase the BMI, cholesterol will also increase. And like if you want to have a plot, you can click on this plot and you will get a plot, correlation plot between this cholesterol and BMI. So it appears like that you have to see this cholesterol and this BMI. So this is your simple correlation between bivariate correlation between two variables. Now, if you want to have the other variables, like what was the question? So it was cholesterol, cortisol, and vitamin D. So go to Jamovi. So cholesterol, cortisol, vitamin D. And then you can see the correlation between the two values. So now how to read this table? Again, we have done that. There is a column and there is a row. So this 0.076, this tells you the correlation coefficient between the cholesterol and cortisol. This is very low and this is not significant also because p-value is 0.3. Now coming to the correlation coefficient of cholesterol and vitamin D and cortisol and vitamin D. So cortisol and vitamin D, this is also not significant, but this 0.245. So you have to focus on the star marked. That's why you have clicked on this flag significant correlation. So there's only one correlation which is significant here. That is the correlation between the cholesterol and vitamin D. If you come down, you can see here that there is a graph of these two. This is the correlation matrix plot that you can see here. And this you can paste it. So there's significant but mild. Which one? That 0.245. Anju, you are talking of which significance but mild?
Ma'am, vitamin D with cholesterol. It's 0.2.
Okay. Strength you are saying. Yes, true. True. So it is less than 0.3. So that's why it is not a very strong correlation, but mild correlation. True. So that is there with the correlation. Now how to write interpretation? So interpretation is simple here. So before you apply regression, because in regression also that collinearity statistics is there, which people were getting confused. So this is how you will write the write-up, that a Pearson product moment correlation was run to assess the relationship between the cholesterol concentration and BMI. Scatter plot showed that the relationship is linear, no outlier. QQ plot, those things you will write box plot inspection. And then you will write that there was a significant correlation. You can give the value that 0.675. And you have to write the R square also. So you will write the value of R square. And then you will write the explanation that this much percentage of variation in the BMI was responsible to the variation in the cholesterol. Okay. So this was regarding the bivariate correlation. Multi-correlation, this is the matrix. And you can directly copy paste the values also. And this is the write-up. So this was regarding the correlation.